What's up? Algebra 2 classes, Block 3 and Block 5. Miss you guys. Hope you had a good weekend. Today, as you know, we are doing asynchronous learning only, which means that I am not going to be live with you. So I just made this video to kind of walk you through what I want you to do today, and then we'll practice a little bit too later on in this video. Okay, so first there's a video to watch, which is on kind of the last type of transformation. Hopefully you watched the one over the weekend on vertical flips, okay? But then, yeah, this one's going to be that last one on that A value transformation, okay? So watch through that, again, like 15 minutes. And then what I'm going to do here is just practice with you on the board. I'm just going to give like one or two problems, and then I'll have you like pause the video at a certain point, and then you can practice yourself, and then I'll walk through it right after. So, all right, Algebra 2, we're here. We're going to be graphing some of these puppies, okay? Some flips and some A transformations, right, where you have that A value in front of the X, okay? So we're just going to practice with these. And so what I want you guys to do, like I said, is just pause the video, okay? If you've got graph paper at home, try to graph these yourself. Again, the process is the same as when we just did those horizontal and vertical ones, where you start with the parent function and then shift around horizontal or vertical first, but then you would perform any flips or anything. So just take a second and try these. I'll just give you a second to pause the video, but if you don't quite get it yet, then just stick with me and I'll walk through these right after. Okay, so pause the video here, try these yourself. All right, so hopefully you were able to try it. Let's get into it here. Okay, so looking at number one, okay, y equals negative square root of x plus 3. Okay, so our parent function, again, that's how we start. Our parent function is our square root. Okay, and so again, we start by sketching that on here. Okay, so again, that's 0, 0, 1, 1, 4, 2, 9, 3. So there is the graph of this, okay? And so what I want to do is shift that around, okay? So now what I have to do is look at the actual equation and determine what are the shifts. What's going to be happening to this, okay? So when I look at this, again, I notice first this plus 3, right? That plus 3 is in a group with the x. So again, remembering from before, in a group with the x means that is shifting left or right. And plus means that's shifting left 3, okay, shifting left 3. All right, so my vertex point is going to be shifting over 1, 2, 3, and I can draw that right now because my vertical flip is not going to affect where the vertex is, okay? So yeah, but that is another one. It's going to do a vertical flip. Okay, so that is that. Okay, so what does that mean? So again, this is where my square root is going to be, right? That's kind of the origin point. But again, it's going to flip vertically. So instead of going up like this, it's going to go downwards. Okay, so I almost want to make like the mirror image down below here. Okay, so how that's going to look is instead of going up 1 and right 1 from the vertex point, I'm going to go down 1 and right 1. Make a point there. Okay, instead of going up 2 and right 4, I'm going to go down 2 and right 4 from the vertex point. And then the last one, instead of going up 3 and right 9, I'm going to go down 3 and right 9. 3, 6, 9 right there. Okay? So that is the vertically flipped version of this and shifted left 3. Okay? So that's that one. Okay? And again, as always, given the domain and range. Okay? So those aren't going anywhere. We still have to deal with them with the tougher graphs here. Okay? So the domain for this one, again, left to right. So again, it's going to go to the right forever, right? That's what this line is, that arrow is saying. But it does not go left forever, okay? It stops. So the furthest left that it ever goes is -3 on the x-axis, okay? And then it's going to get greater and greater and greater. So we'd say x is greater than or equal to -3, okay? But then for the range is interesting, right? Normally we would say with the parent function, this is going gradually very gradually going up forever, right? But here, right, we see it because it turns upside down, now it's very gradually going down forever, right? It never goes into the positive y values. It's only going down, right? -1, -2, -3, those are those y values. It's going to go to -4, -5. So we'd actually say y is less than or equal to 0 because it's at 0 and all the values lower than that on the y-axis, okay? So that's it for number 1, okay? Number 2, y equals 2 times the absolute value of x minus 7, okay? So same thing, we want to look at this and we want to think, okay, what are the transform? Well, first, what's the parent function? And the parent function here is that absolute value. So again, we sketch that. That's the v, right, starting in the middle. Up 1 over 1 to both sides. Up 2 over 2 to both sides. Here it is, okay? And then I look at the equation and I think, okay, what shifts are happening, okay? And again, I see this 2 and I see this -7 outside of a group with the x. It's not in the absolute value, it's outside of it. So that -7 is a vertical shift of down 7, right? So that's where my vertex point is shifting. So I take the vertex and I go 1, 2, 3, 4, 5, 6, 7, down 7. And there's no number in here added or subtracted onto the x in the group, so I'm good to just put that right on there, okay? But then that 2 on the outside, right, that's what you just saw the video on. That's a 2 times multiplier, right? That's indicating that we are going to double the vertical distance that these points are normally from that origin vertex point, okay? So in like for these points, and what might be helpful, I did this in the A video too, you might have seen, it might be helpful to just draw like little guide points down here of where they normally would be. And then again, you're kind of doubling that distance, okay? So for these points right here, and it's only doubling the vertical distance, the horizontal distance, the side to side stays the same, okay? So instead of moving up 1 and over 1 to both sides, I'm going to move up 2 and over 1 to both sides. So this is where those actual first points are, okay? And the second points are usually up 2 and over 2. Now we're going to move up 4 and over 2. So this absolute value is a lot taller and skinnier of a V shape, okay? So that, and you can get rid of those guide points after you draw it if you want. If you're a little bit OCD like me, that might get on your nerves. But there it is, okay? So that is the absolute value shifted in this way, okay? Now talking domain and range, domain, well, it's still going to extend left and right forever, right? It's not going to spread out left and right as fast because it's a taller V now, but it is still going to get there eventually, okay? So we would say all real numbers for the domain, okay? And then for the range, is it going to go up and down forever? No, just like the original, right? We would say it's going up forever because these arrows are pointing upwards, but it only goes down. What's the lowest it ever goes on the y-axis? Down here at that vertex point, right? And that is at -7 on the y-axis, right? So I would say it's going to get the -7 and all the y values above that, or we could say y is greater than or equal to -7, okay? So that's the first two, okay? That's the first two, just a basic review of those. Let me do a couple more, if you'd stay with me, just a couple more just to make sure you got it. I'll do some trickier ones, and then we'll be good, and you can get started on that big homework packet. It's not due for a while, though, so don't worry. Alrighty, I've got 3 and 4 up here, okay? And tougher equations. Don't be scared. You can handle it, okay? Pause the video here. Try these yourself, graphing them, okay? Please do. Please put just a little bit of effort in. You all could graph the parent functions of these. I know you know how to do that, okay? And the basic horizontal and vertical shifts. You can do that too, okay? Try these, the flips and the A transformations too. Just try it. If you mess up, it's no big deal. That's what practice is for, okay? Okay, so just pause it, practice, and we'll get into it here soon. All right, so just to save some time, I put up the parent functions already. Okay, hopefully something you were able to do too. This is a cube root parent function, right? We see the cube root in here. And again, that's the one that looks more like an S, more elongated curve, right? Where the cubic one is the taller one. Okay, similar shape though. And then this one's a quadratic with that 2 exponent, right? So I draw my parabola shape. Okay, well, let's get into this. Okay, let's talk about what the transformations are. Okay, so for this one, negative 2 times cube root of x. So what we don't have are vertical or horizontal shifts, right? Those are numbers added or subtracted after the x. Okay, so it's actually the origin point for my transformation graph is actually going to still be in the middle, which is cool. Okay, but for this, okay, for this negative 2, what does that mean? Well, there's two things in there. Even though it just looks like a single number, there's two things. There's the negative, which means it's a vertical flip. And there's the 2. So negative 2, so that means a 2 times multiplier as well. Okay, so two things going on there. All right. So let's take care of the vertical flip first. And I'm going to draw those little guide points in there like I did before too. So again, a vertical flip just means we're taking and we're reflecting across the x-axis, okay? So that means that I am going to take these points and move them that many spots just to the other side and flip it around, okay? And this isn't going to be the final graph, right? I'm going to draw these little guide points in here because we have to make it a little bigger too. So again, this point right here is normally up 1 and right 1, and it's going to move down 1 and right 1. Just flipping it to the other side of that x-axis, okay? Same with this one. Left 1, down 1. Now it's going to be left 1, up 1, right here, okay? This point is up 2 over 8. Now it's going to be down 2 over 8 to the right. And this one is down 2, left 8. Now it's going to be up 2, left 8, okay? And so again, you can draw a little dotted line here. This is what it would look like if it was just negative cube root of x without the 2 there, okay? But there is the 2, so this isn't the graph. So let me get rid of these dotted lines. All right, so again, vertical flip, did it, took care of it, flipped it around. Okay, the s is now going the other way. All right, now, again, 2 times multiplier means we are doubling the vertical distance, but from where it normally would go from that origin point. So these 2 points in the middle here, they normally go up 1 and then down 1. They're going to move the same amount horizontally, left and right, but they're going to move double up and down. So this point right here, this one that right now is up 1, left 1. Now it would be up 2 and left 1. So that big orange point is where this one would be with that 2 times multiplier, right? This point here, instead of going down 1 and right 1, with the 2 times multiplier, it'd be down 2 and right 1. Again, doubling that vertical distance, okay? And then again, this point right here is now down 2 over 8. Now it's going to be down 4, doubling that vertical distance over 8. So that's where that actual point is. And then this one is up 2, left 8. Now it's going to be up 4, left 8. Okay, doubling that vertical distance. Okay, so this very wavy looking graph, that orange graph is this transformation done. Okay, just stretching it out vertically. Okay, and so the domain of the orange graph, the domain, what is it? Well, that's going to be all real numbers, right? It's going to go left and right forever. And again, like the parent function 2, the range here will also be all real numbers because, yes, this will very gradually climb up and down and go up and down forever. So all real numbers for both. Okay, so that's number 3 with both of these transformations going on. Okay, now number 4, tricky. Okay, number 4, y equals 1/2 times x minus 4 squared plus 3. This looks tricky, but I think this one, number 4, is actually going to be easier than this one was. Okay, so if we look at number 4, okay, it's quadratic, so I drew that up there. What are my shifts? What are my transformations? It's minus 4 in a group with the x, so that's horizontal, right? And that's telling me right 4. Okay. Next is plus 3 is telling me up 3, right? Because it's outside of a group with the x, and plus means up. And then this 1/2 means, yeah, I can write 1/2 multiplier. And that means, again, this is going to be a fatter and wider looking curve, okay, than it normally would be, because I'm going to cut that vertical distance in half. Instead of like a 2 stretches it vertically, 1/2 shrinks it and kind of, it's like stretches it out horizontally almost, okay? But first, let's take care of these vertical and horizontal because these are easier to deal with, okay? So I move my origin point right 4 and up 3. So right 4, up 3. So this point right here is almost where like my new origin point is, my new vertex point, okay? And again, what you can do is draw little guide points for you from where, like if it didn't have this 1/2 here, what it would look like, okay? So you go up 1 over 1 to both sides, up 4 over 2 to both sides. That is what a normal shaped quadratic would be if it shifted there. But again, this 1/2 multiplier means I take my vertical distance, cut it in half from what it normally is. Okay, so these 2 points right here that I move up 1 and over 1, now I'm going to I cut that vertical distance in half. So I go up 1/2 over 1. So it's going to be right in the middle of those, kind of going right there. Okay, so you're kind of, but you're not right on a corner, you're kind of between. Okay. And then these 2 points up here, normally I go up 4 over 2. Now I'm going to go up 2 over 2. Again, cutting the vertical distance in half. Okay, I keep repeating that because that's what needs to register, cutting the vertical distance in half. Okay, so you can see that this is a lot fatter and wider of a curve than the original one. Okay, so that is this transformation. Okay, and then again, domain and range. Domain, it will extend forever left and right, like all quadratics do. And then the range, okay, does it go up and down forever? No, it's going to go up forever, but it's not going to go down forever. The lowest this maroon curve ever goes is here, and that's +3 on the y-axis. So we'd say y is greater than or equal to 3. There's a little taste of flips and A transformations. Okay, I know this is tricky. This is when transformations are at their hardest. But you're okay. You're fine. Even if you didn't get these 100%, no big deal. Lots of practice with these makes it easier. Okay? So all I'm going to ask you guys to do for the rest of the class here is I emailed you guys and I put it in the on my Canvas page too. Like I said before, you guys, instead of giving you an assignment due next class, I wanted to give you, it's 4 pages, which is a lot, but it's not due for like 2 or 3 weeks. Okay, so you got plenty of time to work through. Okay, it's just on all this stuff, graphing transformations. There's no other transformations to learn. So like these problems are as hard as it's going to get. So, and if you don't get it yet, no big deal. You have plenty of time to practice. So that's it though. Okay, so I'll see you guys on Friday. Hope it made sense, and thanks.